In this video I discuss briefly the concept of functions. A function is a mathematical relationship that gives one output value for any input value, and so the function of x can be defined in terms of it's x squared plus 7x plus 12. That's a relationship between the input value x and the output value function of x. Then, if I decide that x is equal to 2, I can calculate what the function is at that point by substituting x for 2 in each place that it occurs. So the function of 2 in this case is 2 squared, because it's x squared, plus 7 times 2, because it's 7x, plus 12, and that gives me that the function of 2 is 30. And I can do the same of minus 2, being very careful that every time x is replaced, it's replaced by minus 2, and if we're going to do that on calculators or whatever, then we have to use brackets to ensure that all the squares are correct. Minus 2 squared is 4, 7 times minus 2 is minus 14 plus 12, and the answer is 2. So the function of minus 2 is 2. You've actually met a few functions before, although you didn't always recognise them as such. We have sine, cosine and tangent, where you input a value, in this case pi, and you get one output value, in this case minus 1, allowing for the fact that in trigonometry and from this time onwards we'll be using radians. Another function we know is log. I'm assuming this is log base 10. Log of 100 is 2. However, for differentiation, we're just going to be using polynomials, and they're going to be powers of whole numbers. The function of x is defined only in terms of a certain multiple of x to a power in a string like that, and in practice that's just the same as all those graphs we've drawn over the years. Y is equal to. You've got to get used to working with either form, although obviously the function form takes more getting used to for students used to the old y is equal to notation. When we graph them, they're just the same, except y is replaced by f of x, and it's otherwise plotted identically. Bear in mind that when you have a point that is under the old notation x and y, that under the function notation it's x and then the function of x. Function of x replacing the y. Our test for a function is that for any one x value there can be at most one y value. Here we have a hyperbola that x is equal to minus 1, y is equal to 5, x is equal to 2, y is equal to 1 1/3, x is equal to minus 3, y is equal to minus 5. Each input value there is only one output value. Doesn't matter how wiggly the graph gets. Vertically, at each x value on this graph, there is only one y value. But not everything is a function. This is y squared is equal to x, and for each x value there are two y solutions. So this particular one is not a function.